Good morning, everybody. This is Mr. NK. I'm sorry I'm not there today, but I did want us to start on our amortization tables. That is 7D. Yesterday we finished up 7C, so here we are on to 7D. Take a second to write down your essential question. The essential question is, how do mortgages actually work, and how can I pay them off? As with any debt, I encourage you to do your best to pay off debts quickly. The faster you pay off the debt, the more you have that money free for other things, like, oh, I want to go on a cruise or anything like that. All right. So go ahead and write down your essential question in 7D. Don't forget, your notes need to be out, of course. How do mortgages actually work, and how can I pay them off? So let's go to our warm-up. Every month we gain interest on a loan. How can we pay off a loan if we keep adding to the balance every month? What do you think the answer is to this? Go ahead and think through your own answer, and we'll talk about the real answer in just a second. All right. Now, how can you pay it off if you keep adding to the balance every month? It's pretty simple. Pay more than what the interest Okay, you want to pay more than what the interest is. That'll help you to start paying it off. But most of the time, that doesn't pay it off very quickly. If you are doing this with a credit card, you will pay off the credit card extremely slowly. So much so that it's going to take you several years to pay off a credit card. Whenever I first became an adult, I got a credit card, spent $1,000 on it, and it took me like 3 years to pay it off because I didn't think to not pay the minimum payment. Don't be like me. Make better choices. All right? So, when you pay off any debt, there are 3 possibilities. Okay? The first one is if you pay less than the interest. If you pay less than the interest, what happens? The balance increases. And there's going to be more interest next time. Okay? In other words, you will never pay it off. Because all you're doing is borrowing more and more money because you're not even paying the interest payment. You're never going to pay it off. But what if you pay off the interest? Then the balance stays the same. From whatever you buy, if you pay off the interest, the balance stays the same. What ends up happening is that interest goes directly to whatever your, or that interest just goes away from you. You don't actually get to use it to purchase the thing that you're actually trying to buy. So if you're buying a car and you only pay interest payments, all you're really doing is keeping the car in the hands of the car company that you bought it from, or that you got the loan from. So you pay interest, the balance stays the same, you never pay it off. In both of these cases, we do not pay off our results. So, what if we pay more than the interest on the account? Well, then the balance will drop. And over time, you will pay it off. On a side note, if you just saw that text that came in, I'm going to show you that real quick. This is a bad text. Look at this. It's just a picture and then a PDF document, which is probably a scam. The United States Postal Service does not send us things like this. So if you ever get that, understand it's a scam. Don't think, maybe I should click on it. It's a bad idea. All right. So if you pay more, the balance will drop and you're going to pay off over time. The more you pay, the faster it's paid off. It's not a complicated situation, but if you pay more, and I put more paid, the faster it's paid off. The more you pay, the faster something's going to get paid off. If you have a loan and you want to get it paid off quickly, pay off as much as you can each month so you can get that payoff quickly. Now, we're going to go over the concept another time. We'll do this tomorrow. But for today, we're going to turn the page and go on to the practice problems. Because the first page of practice problems are things you can do without understanding our amortization tables. Now, an amortization table is a table that we create. And we're going to introduce this on the next page right at the end of this video. But we just want to jump to the practice problems. We'll do the concept tomorrow. All right. So think back to chapter 3. What was the monthly payment formula? This was all the way back in October. Many of you may have forgotten it, but I want you to try to remember it. We usually start it with MP, monthly payment. All right, think about what that monthly payment formula might be. And if you don't remember, I'm going to give it to you. Our monthly payment formula is the principal times the rate, this is the annual percentage rate, divided by 12, okay? And then we multiply that by 1 plus the rate divided by 12 to the power of 12t. Now, the reason we're to keep doing the 12, if you remember back in chapter 2, that is how many or how often that interest is compounding. This interest is compounding monthly. Anytime we have a monthly payment formula, the interest is usually compounding monthly, so we use that formula. Then we divide this by, lost my train of thought here, by the 1 plus the rate divided by 12 to the 12t, then we subtract 1, because we're like, all right, what is that value without that plus 1? But we need to do that after the power. So we subtract out that, and we end up with our monthly payment. Now, keeping in mind, we have our 3 values here. The P is the principal. R is the APR, and T is the time in years. Okay, knowing those 3 things allows us to come up with our monthly payment formula. So if you're buying a car or anything like that, you're getting the car for 8 years at an 8% rate or a 6% rate. You plug those in, and you would write out what your principal is. Oh, I'm getting a $30,000 car, to find out what the monthly payment is. Our monthly payment for our amortization tables, as we're going to go through them, is actually this, but we're going to have a slight change. Instead of principal, we can also call this the balance. What is the remaining balance on your account? All right, go down to the next problem. You want to calculate the monthly payment for Heather. Go ahead and calculate that monthly payment. Now, I'm not sure if they brought the calculators back just yet, but if they did not, you can always open up Desmos on your computer. You go to desmos.com. Okay, and you can type in this function in the same way that we would do on the computer or on the calculators. Also, there are 2 calculators up by my desk. 2 of you can grab those, just put them back at the end of the period so other classes will be able to have them. With our event yesterday, I just don't know if the calculators will be back in time. So go ahead and use this formula to calculate her monthly payment. And then we want to find out how much she'll pay if she pays the minimum monthly payment every single month. And then how much did she pay in interest? This is something that we talked about a lot in class back in chapter 3. So you should be able to calculate these things, but in just a minute I will give them to you as well and show you how we can plug them in as well. All right, let's do it. So Heather is planning on buying a home. She has a principal of $190,000. She has a rate of 6.4%. That translates to 0.064. So that's what I'm going to use in my calculations. Remember, we never use that rate. And then the time is a 30-year fixed loan. Now, in this class, we focus mostly on fixed loans because variable loans are variable. It would be hard to come up with the proper equations for them. But fixed loans can actually be used to estimate variable loans. All right, so we've got our principal, our rate, and our time. Let's go ahead and plug it into the monthly payment formula. Now, a good secret is to use your pencil. Just circle the one up here, click that, and you can just duplicate it and bring it on down. That's what I'm going to do right here. Whoa. And with that, I will erase these things, and I'm going to replace them with their actual values. So this is 190,000. Our rate is going to be changed to 0.064, 0.064, and 0.064. And then our time is going to be replaced with 30 for 30 years. All right, with all that taken care of, we want to plug it into a calculator. So pull out Desmos, pull out something else, plug it in. I've got my calculator right here. I'm going to make this a little bit bigger so we can have a bigger screen. I'm going to clear the whole top row so you guys can see it a little bit better. All right. And I'm just going to press 6 so that way it goes to that line. All right. So we've got first a fraction, so I do alpha and x. On Desmos, you're just going to write the divisor symbol, and it'll give you the top and bottom of a fraction. And we do 190,000, one more 0, times 0.064 divided by 12. Close those parentheses. Another parenthesis, 1 plus 0.064 divided by 12. Close those parentheses. Now I'm going to take it to a power. The power is the little caret button above the divisor sign on this calculator, and on your computer, I think it's Shift 6. Now I need to plug in 12 times 30. There we go. I got the whole top taken care of. Now I'm going to type in the bottom. And the bottom is pretty similar to the top. The end of the top there, plus 0.064 divided by 12. Oh, I did times divided by 12. And close those parentheses, take it to the power of 12 times 30. And then I'm going to subtract my 1. Now I've got it. Let's just press enter. And the monthly payment for this is going to be $1,188.47. Now, anytime you're doing a debt, you remember you always want to increase it. You always want to round up, just in case. You never want to have a late charge because you were 1 penny under your payment. So $1,188.47. This would be the monthly payment. Now, this monthly payment is only for the mortgage. This monthly payment is not for everything. So we want to use that, and we're going to find out what she'll pay if she's paying the minimum monthly payment. How much is she going to pay altogether? Well, she's going to pay that amount every month for 12 months a year for 30 years. Okay? So we have 1188.47. That is the payment per month times 12 months times 30 years. All right? And so we need to go ahead and multiply those to find out what it is. 1188 times 12 times 30, 0.47 times 12 times 30. All right, so ultimately she is paying $427,849.20. Okay, so she's paying that much per altogether. So how much will she pay in interest? Well, if I've got $427,000 that she's paying, and the house cost $190,000, I can just do some quick subtraction. $427,849.20 minus $190,000. So I'm going to go ahead and do the subtraction. $427,849.20 minus $190,000. All right, she is paying $237,849.20 in interest. Okay, that's a lot of money to pay in interest. That is more than the cost of the house in interest. Notice, cost of the house is $190,000. She's paying more than that in interest. But what if she pays more? What if she adjusts her payment? And that's where an amortization table comes in. It allows you to determine, okay, how much more do I pay? How much will my balance be every month? What's going to happen to my overall payment? And how long will it take me to pay off this debt? Being able to create this amortization table it's a complicated process, but not too complicated. It ends up being pretty easy. But as I'm talking about this, I think we will do this tomorrow. Just finish getting your notes down on this part, reviewing our stuff from Chapter 3. This was a lot of what we did in Chapter 3. If you remember, this was Big Idea 3B, minimum monthly payments. All right, with that said, we will talk to you tomorrow. I should be back in class tomorrow. Have a good day.